Okay, great, 12. So on this one, we are working on work, energy, and power. So this is what we have. Look at the question. It says that a man pulls a cat with a load or up a hill which forms an angle of 25 degrees with the horizontal, and they tell you that the mass of the cat and the load is 350 kg, and the frictional force of the load on the cart and the load is 180. Okay, he walks a distance of half a kilometer at a constant velocity. Very important. That weight constant velocity is very important. So I'm just gonna try and highlight that part because it's very important. Constant velocity. Okay, so now they say that accept the gradient remains unchanged. Okay, so let's try and answer the following questions. Draw a free body diagram of all the forces that are acting with its load. So now we need to identify all the forces that are acting on that object. So if the object is moving up, we're going to have what we call the frictional force that will go down. This will be my F for frictional force. Then there's a force that always acts down, which is the weight. So this will be my Fg. And then we have a force that is perpendicular to the force that is perpendicular to that, which will be the normal force. So exam tip that I can give you on this question, most cases you'll see that they say this is 4 marks. Look at the mark allocation. The mark allocation will tell you how many forces you need to include on that diagram. Okay, so to answer that question 2.1, I'm going to have a force, which is the force applied, and we also have a force that is going down. Let me just do this. Okay, this will be my Fg. And then we have a normal force, which is perpendicular to the surface, and a force that is opposite to the applied force, which is friction. Right, that is 2.2. So let's look at what, 2.2, they say determine the net work done on the cart and the load. They want you to determine the net work done. Guys, we just said constant velocity. Constant velocity tells us that, remember, F net is equals to ma. So if this moves as a constant velocity, what is F net? The acceleration is 0. This gives us the F net 0. So if the F net is 0, what is the net work done? So the net work done is equals to 0. Please, even when you get in your exam, don't forget to say if this thing is moving at a constant velocity, the net work done, it will be equals to 0. Because F net is 0, he walks at a constant velocity. Right, 2.3, calculate the work that the man does on the cart and the load. So they just want you to calculate the work that is done by the applied force. So I'm just going to give you a quick tip. If they want the work that is done by the applied force, you need to indicate all the horizontal forces that are doing work on that object. So there is this one force that is there, but we did not include it on the free body diagram because this is a component force. So most of the time when we do the component force, we don't include this one. The force is your Fg parallel, which always acts down. So in order for us to do that 2.3, we need to indicate all the horizontal forces. So I'm going to have the F applied, which moves up. Then we're going to have the frictional force, that will be F, and the last one that will do work is your Fg parallel. Right, your Fg parallel. So your Fg parallel. So what I'm trying to do here, I need to find the work done by the applied force, which is the question. Then to do that, we need to know what is the work done by the frictional force and the Fg parallel. So I'm just going to try and put this in writing. So for 2.3, we're going to say that the work done, the net work done, it's equals to the work done by that applied force, then we're going to add the work done by the weight, which is the FG parallel. Don't say FG only, it's the FG parallel, and then we add the work done by the frictional force. Remember, the net work done is 0, so all this should give us 0. So I don't want to waste time on this one. So you know what I'm going to do? I'm going to first find the work done by our FG parallel, okay? So the work done by the weight is going to be the FG, then delta x, the cos of theta. So FG parallel, delta x, the cos of theta. So if I rewrite this equation, the FG parallel, we know that since this thing, okay, it's going to be FG, let me write this down, FG parallel is equals to mg, the sine of theta. Okay, let me put this down here. This is mg, the sine of theta times the cos theta. Then you're going to do your substitution. Make sure that you substitute correctly. So we are looking for, let's look at this. The question said the mass, the mass of the cut and the load is 350 kg. So my mass is 350, and then multiply by G, which is the gravitational force, 9.8, the sine of that angle. So this will be the sine of the inclined angle. What is the sine of the inclined angle? 25 degrees. Okay, so now let's talk about the common mistakes that you guys do. So look at this. We have theta here, and we also have theta here. So please note that this theta is not, we're not going to substitute 25 on both of those angles, because what I need you to understand, because if you miss this information, everything will be wrong. This theta, the cos of theta, this is the angle between the displacement and the FG parallel. We'll talk about that one right now. So look at this. Where is this thing going up? I'm sorry, where is this thing going? This is going up. So I'm just gonna say my displacement is going up. So this is my delta x. This is where we are going. And then where is the FG parallel going? Look at the FG parallel. FG parallel is going up. So the angle between these two is 180 degrees. Right. So the cos of theta, the angle that we use, it should be 180 degrees. So this will be the cos of 180 degrees. I hope you understand how we got with that one, right? So, but we are missing something here. Let's quickly fix this part. This is the cos of, we need to multiply the displacement before we can put the cos. So this will be delta x, the cos of theta. And the displacement was given as 500. Let me just confirm that. Do we have the displacement here? Is it possible that this question doesn't have the displacement? Maybe we're missing something here. They say that he walks a distance of half a kilometer at a constant velocity. Half a kilometer. So if he walks half a kilometer, what is our delta x? Let me quickly work this thing down and see what we get. Okay, so apparently they say that this guy works delta x, which is half a kilometer, which is 0.5 kilometer, right? Then we need to convert. Oh, this makes sense now, because remember, when we work with power, work energy and power, the displacement should be in meters. So we need to convert this into, we need to convert this and put it in meters. And the best way to do this, we need to multiply that by we need to multiply that by 100, right? The 0.5, we need to multiply that by 100, not 100,000. We take the 0.5, you multiply it by 1,000 because we are converting from kilometers to meters, which gives us 500 meters. So the displacement will be 500 meters. I'm very sorry about that. This is something that we were supposed to do first before we do anything to convert that. So I think one of the things that makes this question to be more interesting is that the displacement is given in weights. So you just have to know that half a kilometer, that's 0.5. Okay, so let's substitute that guy there. That will be multiplied by 500 and see what we get. So this will be multiplied by 500, the cost of that 180. Then I'm going to use the calculator to find the work done. I'm going to use the calculator to find the work done. Let's quickly substitute that on the calculator and see what is this equals to. At 350, we have 350, which is multiplied by 9.8, multiplied by the sine 25, and this is multiplied by 500, and this is multiplied by the cos 180. And this is negative 724, 790.32 if we round it off to 2 decimal place. So this is equals to negative 724. We said 790.32 joules. So this is the work done by the FG parallel. We need to find the work done by frictional force, because when we need to substitute this and that. Okay, let's find the work done by frictional force and see what is that equals to. The work done by frictional force is equals to frictional force delta x, the cos of theta. Okay, so I think this one will be easy because the frictional force was given as 180. So I'm just going to substitute 180 there. And the displacement is still 500. The cos of, so you can see that frictional force is also acting down, and which gives us the angle to be 180 degrees because okay, maybe I can also give you an example. If the force is going in an opposite direction as the displacement, just know that the angle is 180. And if the force is going in the same direction as the displacement, just know that the angle is 0. So I'm just going to punch that on the calculator, 180. I'm going to multiply that 180 by 500, multiply by the cos of 180 and see what we get. This is negative 90,000. Okay, so this is negative 90,000. So this makes sense because these forces are going in an opposite direction. They will do a negative work done. So this will be 90,000 joules. Okay, so now let's go to the last part of this so that we can finish working on this problem. Okay, so we just have to take, we said that the work done, the net work is equal to 0. The work done by applied force, we added this with the work done by the weight, the work done by frictional force. Okay, it's equals to 0. Let's substitute the work done by applied force. Then we're gonna add inside the bracket that negative 724, 790.32. Close the bracket, plus into negative 90,000. Close the bracket at 0. Therefore, if I make the work done subject of the formula, we'll take the 90,000. We're gonna add that with the 724, 790.32. The answer that we get is the work done by the applied force. Let me quickly see what we get if we add the 2. So this will be 90 plus 724, 790.32. So when we add the 2, we get 814790.32 joules. So this is the work done by applied force. 814790.32 joules. So that is the work done by frictional force. And that's it for this example. I hope you guys understand everything that we did to answer this question. This was an easy one. So this one is 2 marks, this one is 4, and this one is 4. So all 10 marks. Okay, I hope you guys are happy with how we did this one. And if you really enjoyed the lesson and this is your first time watching my lessons, make sure that you subscribe to the channel, join the family, and also leave a comment, guys. Tell me what you want us to do next. Thank you very much for watching.